Okay, so test review worksheet 2, number 3. Okay, so worksheet number 2, number 3. Find critical points for the function e to the x plus sine 2x in the domain from 0 to 2 pi. So as a reminder, we have a rule for e to the u. It's e to the u times u prime. So we can apply that rule for this exponential function. So y prime e to the exponent will get rewritten times u prime times the exponent's derivative. So x becomes 1. What does sine of 2x become? Times 2. Good. To find critical points, we set our derivative equal to 0. Good. Yeah, each equal to 0. Now the thing here is that the exponential function e looks like this. It's always hovering above the x-axis. So we know that the graph is never going to touch the x-axis. Or algebraically, if you try to take the natural log of both sides, natural log of 0 is never going to make sense. So we're not going to have any solutions here. So there's no critical points to be found with that first expression. We're going to find our critical points from this expression, though. Okay, so I'm going to try to get that cosine of 2x by itself. So I'm going to subtract 1, divide by 2. Okay, so we're not going to have to deal with double angle identities. Rather, we're just going to work with inverse trig. Okay, so we're going to try to get that 2x by itself by moving that cosine over. So 2x is equal to inverse cosine of negative 1/2. So we have to ask ourselves, when is cosine of theta equal to negative 1/2? Yeah, in the third and fourth quadrant. Oh, sorry, second and third quadrant. Variations of power over 3. So 2 pi over 3, 4 pi over 3. Now here's the thing: we have to go a little further out than what we initially think of between 0 and 2 pi, because we're going to eventually have to shrink those measures down. So to find additional coterminal angles, we're going to add 2 pi to our original answers, so we can have enough so that when they shrink, that we can still have our full solution set from 0 to 2 pi. So I'm going to add 2 pi to both my angles. So adding 2 pi is the same thing as matching common denominators, adding 6 pi over 3. So what's another coterminal angle based off of this? Plus 6 pi over 3, so 8 pi over 3. 4 pi over 3 plus 6 pi over 3 is, yeah. I'm going to go a little further out. I like to have more than enough so that I have just reassurance that I did not accidentally miss ones along the way. So 8 pi over 3 plus 6 pi over 3. Okay, that should be enough. So I'm going to divide all this by 2, but rather than dealing with complex fraction, dividing by 2 is the same thing as, yeah, just makes it a little bit cleaner, a little bit easier numerically. So 1/2 times 2, I'm just left with x. Okay, 2 pi over 3 divided by 2. This is really 2 pi over 6, But if I just look at the numerator and try to cancel the numerator out, it makes it a little bit easier here. So this gives me just pi over 3. Four and 2 can reduce to be just 2 pi over 3. 8 and 2 can reduce. 10 and 2 can reduce. And finally, 7 pi over 3. Okay, we only want to keep the solutions between 0 and 2 pi. Are there any that's outside our interval? Yeah, if you think about 7/3, that's more than 6/3, right? 6/3 is exactly 2, so we know 7/3 is more than 2. I like to see one that doesn't make the cut, because I know that I went far enough, right? If I can reach one that is not going to be part of my interval, I know I didn't accidentally miss one along the way. Okay, questions with 3. Okay, number 4, find equation of the tangent line to our equation. Sine pi x plus cosine pi y equals x squared y. Okay, so to find the equation of the tangent line, we first have to find, well, we have our order pairs. We're going to find the derivative, and then from the derivative, we can evaluate the derivative at a point to get to the slope, and then we'll put it into point slope form. So to find a derivative, though, I want you to list out what concepts, what procedures are involved here if I want to find the derivative. Good, right, you see y's mixed into the equation here. What else? Good, right, so we need to make sure that we can recognize the need for product rule anytime you see 2 variables that are attached to each other by multiplication. We got to go through product rule. Okay, so let's go through our derivative rules here. Sine of u becomes cosine of u times u prime. Cosine of u becomes negative sine u times u prime. Okay, so sine's derivative, cosine of u times pi, good. Cosine of u becomes negative sine of u times u prime. Okay, u prime, what's the derivative of pi y? Good, pi dy dx. Pi stays because it's a coefficient. Y will turn into 1, but then the dy dx will be included. Okay, so now the right side is where we have to involve product rule. F prime g plus fg prime. X squared becomes 2x times g plus f. Okay, what's g prime? Y's derivative is dy dx. I'm going to rearrange this, try to get dy dx by itself, and then I'm going to work in my order pair to get to my slope. So I have 4 terms here, right? Yeah, so this is 1 term, 2nd term, 3rd term, 4th term. I want my 2 dy dx terms together so that I can factor out a dy dx. Okay, factor out dy dx. Divide the parentheses over, isolate dy dx. Okay, so now we're ready to evaluate the derivative at a point. Replace all the x's with 3, replace all the y's with -1. Okay, any questions so far? Okay, let's get this cleaned up to be a little nicer here. This is -6. Now, you may be looking at cosine 3 pi and sine of -pi and not knowing exactly what those values are. You know that you can always get coterminal angles into the range from 0 to 2 pi by just adding or subtracting 2 pi until you get it into that range. So 3 pi, maybe you don't recognize that, but I can subtract 2 pi from this. 3 pi minus 2 pi is pi, so cosine of 3 pi is the same thing as cosine of pi. Right? And cosine of pi is what? -1, okay. You may not recognize sine of negative pi, but negative pi, you can always add 2 pi to get it into that interval. So negative pi plus 2 pi is 1 pi. And what's sine of pi? 0. So same thing as sine of negative pi, also 0. Okay, so we're going to just use that to help us clean up all the way down to a cleaner number. This is -6. Cosine of 3 pi is -1. -1 times negative pi will be a positive pi. Sine of negative pi is 0. 0 will take everything else with it. And then we're left with a -9 below. Okay, there's our slope. So now we have our slope, we have our ordered pair. Now we can do point slope form. Yeah, so numerator here, 2 times 3 times -1 is -6. Cosine of 3 pi is same thing as cosine of pi. And cosine of pi is -1. And then -1 times negative pi will be a positive pi. Okay, any questions with 4? Okay, let's flip to the next page and we'll do a related rates problem, number 5. Now we're focused on trig for related rates, so you know your related rates problem will always be a triangle, okay? Because we're always going to be finding d theta dt, and it's always going to be in relation to a triangle. Part A is going to be a review of Pythagorean theorem, and then part B is where we're going to bring in that d theta dt. Okay, so right triangle. person X and person Y are walking along straight streets that meet at right angles. Person Y is traveling south. Person X is traveling east. Okay, so here's my right triangle. Y travels south, approaches the intersection at 2 meters per second. Person X travels east and moves away from the intersection at 1 meters per second. Find the rate at which the distance z between person X and person X and person Y is changing when Y is 10 meters from the intersection and X is 20 meters from the intersection. So part A, just a Pythagorean theorem problem. Okay, let's go ahead and find the derivative because we know the derivative will just show all of the variables that we need. X squared becomes 2x, attach dx dt. Okay, let's list out all the variables that we have to involve here. X, Y, Z, dx dt, dy dt, and dz dt. All right, let's go back to the problem and see if we can assign these values here. Y travels south and approaches the intersection at 2 meters per second. What can we assign 2 meters per second to be? Good. There's movement involved, right? Meters per second, there's time involved. So any adjustment that we need to make? Okay, Y is a negative.
It's getting smaller.
Good. Not because Y is going south, right? The direction has no impact on the sign. It's because this length is getting shorter. So Y is decreasing at a rate of 2 meters per second. So we need to include that as a negative. Person X travels east, moves away from the intersection at 1 meter per second. Positive or negative? Positive because X, not because it's moving right, but because this horizontal length of the triangle is increasing as time passes. Okay, part A, let's see, continue reading here. Find the rate at which distance X is changing. Sorry, distance Z is changing. What are we looking for here? Yeah, so that's our goal for part A. We're trying to find dz dt. Okay, when Y is 10 meters from the intersection, and X is 20 meters. So we have we still have to find Z. How can I find Z before we put into our equation? Okay, Pythagorean theorem, a squared plus b squared equals c squared. $20 squared is 400. Okay, take the square root. We can leave it as square root of 500, but we can break this down without too much trouble, right? We know there's a hidden perfect square inside of 500. Think of it as 100 times 5. You can pull that 100 out as 10. So you can either say root 500 or a little bit cleaner would be 10 root 5 for Z. Okay, let's put everything into our equation and solve for dz dt. Okay, so 2 times x times dx dt plus 2 times y times dy dt equals 2 times z times dz dt. (40 minus 40). Okay, this ends up giving us 0, right? But it's not like a ladder problem where the hypotenuse is always a constant. It just so happens that at this moment in time, that distance between x and y is not changing. Okay, part B. At what rate is angle theta changing at that moment? So it doesn't specify where theta is for the problem, but on the test I'll specify where that location is. So theta is the bottom corner. Let's practice. We can use any trig function, but let's practice using tangents. Just have that, get that practice in. So let's start off saying tangent theta is equal to y over x. Okay, the reason why we could choose any trig function is because we have everything that we need, right? Everything is provided, so we could do any variable, but let's practice with tangent. Okay, so tangent's derivative. Times related rates, right? So we need what? Get d theta dt. Okay, the right side, both of these are variables, so we have to go through quotient, right? Quotient rule, yeah. F prime g minus fg prime all over g squared. The right side, we can replace all these values with what we found from part A. What's new and different is understanding how to deal with this trig ratio, right? Make sure that we understand we don't care about what theta is. We want to replace the entire trig function with the ratio. So I'm going to gather that information on the second triangle. I'm going to draw a second triangle so I can have that very clear. I'm going to populate the sides with information that we've gathered from part A. So we know the x value, we know the height, the y value, and we know the hypotenuse. Okay, we need to find a ratio replacement for secant of theta. So what's secant of theta based off of this triangle? Reciprocal of cosine, right? You know that cosine is adjacent over hypotenuse. So therefore secant is what? Hypotenuse over adjacent. So secant of theta is going to be 10 root 5 over 20. Okay, just to make it a little bit easier to work with, I'm going to reduce this. What can I reduce this down to be? Yeah, root 5 over 2. Okay, so I'm going to take that, replace it in for secant theta. Make sure that we are squaring the fractional value. I'm going to fit all this in here. So dy dt, just looking at information that I've gathered and just replacing it. So -2, 20. Okay, I do want to move this root 5 over 2 squared over. So this, if I square this, this just becomes what? 5 over 4. If I flip it to the other side, I'm just going to multiply by what? Yeah, 4/5, right? Just taking this and multiplying by the reciprocal to move it to the other side. So this is negative 40 minus 10. Okay, that 4/5 is coming from that 5 over 4, and I'm just flipping it to the other side. Okay, you can leave your answer unsimplified. I know without a calculator, sometimes it's a little messy to clean everything up, but I think this is manageable to clean it all the way up, but you know, it won't take off any points if you're not cleaning up your value. So I can always break down a large number into smaller parts, right? So I think of this as negative 5 times 10 times 4. And the bottom is just 20 times 20 times 5. I can match and cancel out things a lot easier when I have smaller numbers. The 5s cancel out. The 10 and 20 can reduce to be 1 and 2. 4 and 20 can be reduced to be 1 and 5. So the only thing left up top is negative 1. The bottom is just 10. So d theta dt is negative 1/10. What's the unit of measure? Well, with theta, it's always going to be radians. Always radians per time unit. Okay, your test problem will look a lot like this. Okay, so if you know how to do this, you should feel pretty good with what you're going to see on the test. Okay, number 6, curve sketching problem. So from the function, we're going to find the derivative. From the derivative, we'll create a slope sine line, find critical points, populate it, test the subinterval, determine intervals of increase, decrease, relative max, relative min. We'll move on to the second derivative, create its sine line, populate that sine line, determine intervals of concave up, concave down, and then see if we have any points of inflection. Gather all the order pairs, sketch the graph, and then we'll fill out information that they're asking for. Okay, does anybody still need to look at number 5? Okay, number 6. Let's find f prime first. X minus sine x becomes what? Set the derivative equal to 0. Okay, we're extending all the way from 0 to 4 pi, so where is cosine equal to 1? And 4 pi. Okay, so we're just going all the way to 4 pi, so I'm going to include that as well. Okay, once we have our critical points, place them onto our sine line. We do have duplicates in terms of endpoints, so it's just only 2 pi will stand in the middle. I'll choose easy, convenient points to test in between. I'll test pi and 3 pi. We're testing this against the derivative function because I want to gather information about slope. So let's enter pi in for x. What's cosine of pi? Yeah, 1 minus a negative 1, so that's going to be positive. 3 pi. 3 pi is the same thing as pi. Cosine of 3 pi is also negative 1. 1 minus negative 1 is positive. So we know how the graph is going to behave in terms of its slope. It's always going to be a positive slope at 2 pi. The graph is going to kind of flatten out for a moment, but it's going to continue rising. Okay, we'll come back and gather all that information later. Let's move towards second derivative here. So f double prime. Okay, so we go to f prime, we find the derivative, 1 goes to 0. What does cosine of x turn into? Yeah, so the two negatives will cancel out. The negative is in front of cosine. Cosine is going to produce its own negative derivative. So f double prime is just going to be positive sine of x. Set f double prime equal to 0. Okay, so where is sine of x equal to 0?
0.
Okay, a little bit more. Where else is sine 0? Yeah. So pi, 2 pi, 3 pi, and 4 pi. Okay. We have to go all the way up to 4 pi, so that's where we also include 3 pi as well. Okay. Second derivative sine line. Choose convenient values in between, so I'll choose 1/2 pi, 1.5 pi, 2.5 pi, and 3.5 pi. Okay, we're testing this against the second derivative function, sine of pi over 2, positive or negative? Positive, so we know that second derivative is going to be dealing with concavity, so concave up. Sine of 3 pi over 2, negative, concave down. 5 pi over 2 will be the same thing as pi over 2, so back to positive, concave up. 7 pi over 2 will be the same thing as 3 pi over 2, right? They're 2 pi apart from each other. So sine of 7 pi over 2, same as sine of 3 pi over 2, negative. Okay, what do we expect out of this? How many? Do you see any points of inflection? Yeah. Right, so all these critical points end up being points of inflection. There's no relative max, relative min, but we do have 3 points of inflection. Okay, so I'm going to move towards sketching the graph now. So to sketch the graph, let's just go ahead and gather all the information that we need. So let's find the order pairs at the endpoints, and let's find the order pairs at all the critical points. So if I want to find physical locations on the graph, how do I find it? Original, right? Original is always going to give you a physical location on the graph. So I'll step to the side here, f of 0, back into the original equation here. So 0 minus sine of 0. 0, yeah. F of pi, pi minus sine of pi. Sine of pi is 0. That makes it easy for us, just pi. Sine of 2 pi is also 0, so just 2 pi remains. Okay, so we have all these order pairs. Let's go ahead and just plot those points. We have order pairs 0, 0. I'm going to conveniently just mark these as, mark my x and y axis. So 0, 0, pi, pi, 2 pi, 2 pi, 3 pi, 3 pi, and 4 pi, 4 pi. I also always like to do 2 versions of my graph. One version is just based off of my sine line, my slope sine line. My graph is just going to be rising all the way through. I'm not going to pay attention to the curvature, but I do know that 2 pi is going to flatten out for a moment, but it's going to continue rising. Okay, I know it's not accurate, but it kind of gives me a way to kind of update my graph because I know my path of the graph. Now I can go back and give it the appropriate curvature. So I know from between 0 and pi, my graph is going to display concave up. So I'm going to give it a bit more concave up curvature that it needs. From pi to 2 pi, graph is going to be concave down. Between 2 pi and 3 pi, concave up. And then between 3 pi and 4 pi, concave down. So the graph is always increasing, but it does have that additional curvature that we've gathered from the second derivative sine line. Okay, relative max, relative min, we don't have any. Absolute max and absolute min, just look at the graph and locate your highest and lowest y value. Lowest y value is 0, highest y value is 4 pi. Remember, absolute max and absolute min is just dealing with the y value, not order pair. Okay, fill in your points of inflection, concavity, interval, and then make sure you include your because statements. Just practice writing those out. So I may ask you for because statements for relative max, relative min, increase, decrease, POI, concave up, concave down. So see if you can try practicing that. And all you need is just take that information from this concavity sine line and put it into interval notation and write your because statements, right? Point of inflection is because f double prime changes signs. Concave up is because f double prime is greater than 0. Concave down because f double prime is less than 0. Oh, I do want to point something out. On the chapter 3 test, some of you lost points, not because you didn't write your because statement, but because you weren't specific enough. Sometimes you would say because it. If you use the word it, we don't know what that's referring to. So careful with using the word it on AP exams as well. Whenever they see that, they usually are going to take a point off because they don't know what it is referring to. So be specific, right? Name the function that you are referring to. Don't just say the word it. Okay, any questions? Okay, so tomorrow I want us to practice recalling and reviewing derivative rules and inverse trig derivatives. Maybe we'll spend some time beginning of class, just see if we can practice writing out those rules so that we can be ready for it by Friday. We'll do a particle motion problem. I want to do a curve sketching problem every day, so we'll do a curve sketching problem. Okay. Thank you.
So this one, I simplify it so it's secant u, move the 2 over for the product rule. For tan u, secant squared u times u prime. So it's, yeah, it's multiply that.
But see, tangent's derivative is secant squared. So I need a secant squared there.
Secant squared? Tan u secant squared.
That's not secant squared though. That's
I read the overview.
Oh, it's secant u. So I didn't. I said secant u instead of secant squared u. Okay. That was just the second half of my homework.
Okay.
from yesterday.
great. I'll mark you down. Thank you. Thank you. Oh, really?
And also, could you show me where I lost points from?